Hello and welcome back to the development of the Feersum scheme compiler. So in this stream we're going to continue looking at macros. In the last stream we were looking at macro patterns again and trying to expand out our support for the different kinds of macro patterns that are defined in the scheme spec. So that's what we're going to continue doing today. So let's start by going over what we did in the last stream. So all of the work in the last stream was in this macros file. So the macros module is defining the types that we will use to match macros, and it will also, I think, define the logic for expanding macros. But we're still stuck in the how do we match macros part of the whole problem. We're modeling macros, or at least macro patterns, with this type at the moment, which has all the different cases that we've covered so far for the different types of patterns that you can write. So you can either have a constant, which is if you've specified something like a literal, like 3 or whatever, or a string. Underscores, which are like a discard pattern. They will match anything but never bind it. You can have a literal, which is where you're expecting a specific identifier. So if you, for example, want to make sure that someone has used a specific name, like if or cond, for example, if we're defining cond as a macro, we might make sure that else is actually else, rather than having the next kind, which is a variable, where you say match anything and bind it to this specific name. And so pattern variables can be used when we expand the patterns later to copy bits of the input syntax into the output syntax. The next one is a form, which is a list of patterns, and that's expected to match a parenthesized expression, and a dotted form, which again is the same but this time with a dot at the end. And so this covers a fair amount of the spec for the patterns. We've got 2 main holes in the macro pattern spec at the moment. The first one is the fact that we don't support these ellipses patterns, and the second is that we don't support vector patterns. I'm not going to concentrate on vector patterns at the moment, but hopefully today we can get ellipses patterns sorted. Where I'm going to start, however, is by looking at the tests and the way that we test these. So in the macro tests, we've basically got lots of these kind of unit tests which have like either a little macro matcher method inside them, or we just call this assert matches helper, and we provide it with the macro pattern, and we provide it with the syntax tree to match against. And for simple patterns like this one, which is a form pattern matching a form, it's not a huge amount of code, but for some of the more complex ones, it's scrolling off the side of the screen quite a lot. It would be nicer to be able to write the patterns as something along the lines of the actual syntax. So what I would like to be able to do is do like macro parse tests, and have it say something like assert match, and then say something like, if I have the pattern A, that would match this syntax tree 1, and then have it pass the syntax tree and pass the pattern, and I'd be able to say that that same pattern would be able to match like false and we could also have things like if I've got a pattern with two things in it, a variable and for example a literal, and I then try and match that against a form which contains something like test as the identifier and then 1, that would work, and that kind of thing. So what I'm going to do is try and write this. Well, do I want it to be assert match, or do we want something like check match or something like that, and then have it return, and then we can do like assert empty or something. Yeah, something like that. So we'd have this return the variables that it's captured, maybe, or whether or not it matched. Or maybe try match. If you had it try match and have it return an option, which is either none if it didn't match, or it's something containing the match variables. That's probably the best. And then up here we'll do let private try match pattern and a stack. What we're going to do is pass the pattern, pass the syntax. At the moment we'll return none. And assert dot true try match option. Oh, we don't. Yeah, no, we don't have is some. So we want to check that each one of these actually matches something. So to do that, we will have to write some code to parse the macros, but what we can do is we've already got support for parsing syntax trees. So let's do that. We'll parse the syntax, and then the last one is try and match the pattern. Let's make these all to-dos so that I can find them later, and we know that we need to delete them. So parsing the pattern we don't have the stuff for, but parsing the syntax should be a matter of syntax dot parse. We've got parse file, parse stream. Do we have a nice string-based version of parse stream? We have read expression, which returns an AST node. Let's do read expression then. So we do hey stack read expression, or let syntax tree equals read expression a stack. And I think we might have some helper methods which allow us to parse. Yeah, read single does read expression and expects a single one, and it will throw if it doesn't get what it expects. That's just for unit testing, so it's effectively a way of unwrapping the parse results. So read single, and how do we parse the pattern? So I think we're going to say let macro pattern macro pat is going to be, I think we're going to do the same thing. I think we want a method in the macro module which will take a syntax tree and return a macro pattern. So we'll do read single pattern, and then we will call gonna be, it's not like we're parsing it, is it? We're not binding it. We could call it parse macro. Read pattern maybe? Parse pattern. That's parser pattern. I want it to be parse pattern. And then in the macro module, we will do something with that. So let's parse pattern. And at the moment, that's the pattern syntax, and we're just going to ignore that and return a macro pattern underscore or something like that for the time being. So at least the return type of that method should be correct. Is not defined. Yeah, it will be though. So we've got our pattern and we've got a syntax. And then what we want to do is try and match it. So that's going to be macro match. So we'll match, macro match the macro pattern with the syntax tree. And if we get an OK result, we'll return, might as well just return the bindings. And anything else will return none. I'm wondering whether or not there is a way of doing this. Syntax tree, expect it to have, but here it has AST kind. Read single is returning a kind. Read single node maybe? Which? Yeah, we'll do like read single node. Input, and then this is going to do most of what's in here. So copy paste, and it's going to say if it was a sequence, then do exactly one. If it was a single expression of any other kind, return it. And expected, that's fine. And then in here we can do read single node dot kind. And everything should still continue working. And in the macro task, we want to do read single node. Let's run the tests. So I think that should work. By work, I mean the test should at least pass now, because we're returning an underscore, so it'll just match any of these things. But we actually do want the macro parsing stuff to work properly. The fact that we haven't seen any output probably indicates it worked. There we go, yeah. So the macro parsing, how do we parse a macro pattern from a piece of syntax? Well, it's going to be a function, and it's going to take a piece of syntax. So it will say if it's got we're not going to do that. We'll do we need to kind of switch over the kind. So match syntax.kind. Syntax kind. So what types of patterns? We've got constants, and that should be fairly easy. Constants are going to be AST no kind constant. We'll do macro pattern constant. And if we have well, the next one is underscore, which is going to be an identifier. Literals and variables are also identifiers. So I'm going to leave those for the time being. Then forms. So if it's a form, we will return list.map pass pattern over the list, and we will make a macro pattern form. This needs to be recursive. So what other kinds of, we've got the identifier. And we'll need to take some extra information for the identifier, because we kind of, there's a few different special identifiers that we need to recognize. If it's an underscore, or return an underscore. We've also got variables and literals, but for the time being, we'll just say any other ID will just return as a variable and put it to do. Need to support literal identifiers. So we've got forms, constants, and idents. What other kinds have we got that we're ignoring here? Dot. If we just see a dot, just see a dot in our macro pattern, would we expect that to match identifier and bind it to dot. I'm not sure. I think sequence quoted. I'm not sure. Vector, byte vector are unsupported. So if it's a sequence or if it's an error. We kind of just want to return. I think this should probably return a result. So it would be, that would be okay. This would be okay. This whole block, I think. Because I think whatever ID we've got, it's going to turn into something valid. That needs to be indented more now. In fact, we can do that with a pipe instead. So we'll just do that. If it's this, we can do form. Okay, like that. That right? Do I need to put? Yeah. No. Does not match the type. Macro pattern. Is that result collect thing? Did we do? Yeah. We did collect results. So collect results is going to give us a list, and then we're going to map the result into a form. So we get collect results, which results makes a list, and then result.map. I'm going to break this onto multiple line. Results.map. I think we can just get away with macro pattern form here. That's going to be the constructor function. I think that works. And then anything else is just going to be an error. I don't. We have to use result.error because we've aliased it with the AST node kind error. Do we want to provide any more information here? See, we could provide a diagnostic, which might be useful. Yeah, let's provide a diagnostic. Diagnostic. And this takes a location and a string. So I think if there is an error already, we could just catch you. We can just say invalid. We've got the syntax position, which will be the first part of our error. And we can just say invalid macro pattern. Look at that. What are you complaining about? Value is not a function and cannot be applied because it needs a pair like this. So we make a diagnostic and return that. There are still other forms that we don't handle. So we don't handle the, I'm going to put the two vector types in here. So vector and byte vector, and say it's an unsupported thing. And I'm not sure about matching on quoted things. I don't think you should have to quote stuff in a macro pattern. But maybe quotes should be constants. Vector or byte vector or quoted, and then we'll say this is unsupported. Same thing, location unsupported, macro pattern element. There we go. And quoted needs a discard as well, because quoted forms contain values. So what are we missing now? We are missing dot. So it's a dot. What would it? A dot in a pattern would be an error, I think. Unless we were inside a form and trying to recognize a dotted form. So we'll say, like, I'm going to import diagnostics. Open diagnostics. We'll say diagnostic at syntax location unexpected dot. And then that should be everything in the kind covered. I'm just gonna prefix vector by vector and quoted, because then everything is the same. So we don't support dotted forms here as well. Add support for dotted. We'll have to do some kind of list fold kind of thing like we do when we're matching or making the patterns for lambda arguments. I think some of the parsing of patterns is going to be similar to that. So the same kind of thing where we walk through the list of elements in the form and try and work out whether there's yeah, we keep track of if we've seen a dot, and then if we have a dot, and then we'll produce a dotted form. If not, we'll produce a plain form. And we'll also, I'm kind of leaving that bit undone at the moment, because the other thing that we will do in that walkthrough there is parse the ellipses patterns. So parse pattern takes a piece of syntax. We're going to want to add other things in here as well, because really to parse a macro pattern you need to know a few different things. You need to know what the ellipses identifier is going to be and what the literal identifiers are. So at the moment we're just producing variables for everything, but what we need to do is say, is the ID our ellipses character? If it is, return the ellipses, and then if it's in the variable list, then return the variable one, otherwise return return a literal one, otherwise return variable. But for the time being, this should make that unit test pass. So while it was passing before, it should not make it fail. Oh, it's not the unit tests. This is the unit tests. So hopefully we should be able to pass that as a constant, that as a constant. This is a form with two patterns inside it, but we can't. Why? Because we were expecting macro pattern to have the type macro pattern. Because it returns a result. And what's the best way? Result dot kind of want just an unwrap, but I think we need to match it. So we'll do match. Let's just put it all on one line. If it was okay, we'll return it. If it was an error, we will throw. Could not pass macro pattern, and then we'll dump that. What's wrong there? Macro pattern, yeah, but you will eventually realize that passes. I'll break this onto a new line. How about now? Does the unit test pass now? Compiling is a good step in the right direction. 198 still passes. Good. So we can just add some more, I guess. And these could be, well, we'll leave the macro pass. I'm thinking about making them into theories here. We could have just a theory test which takes the pattern and the syntax to match it against. So let's do that. Macro pass is going to take pattern, syntax, and it's going to be a theory, and we'll just do a whole bunch of inline data. So let's copy and paste this all up here and then multi-cursor the whole thing. So this wants to be inline data. That. Get rid of that. And now, how do I get to the middle? Give up and do it one by one. Sounds like a good plan. And then in here, we want to say assert try match pattern syntax is some. We can add some more tests. So how about a pattern that we've got literals, we've got variables being used here. How about a literal pattern that matches false? And how about a literal pattern that matches 1? I'm wondering about like doing the difference between the different floating point expressions. That might be. The next one we really want is the ability to do the dotted forms. So let's write a test and then have it fail because we don't support dotted forms yet. So in the same thing, we should be able to match that with the pattern a.1. So this should match the dot 1 should match the tail there because the tail's a single element list. I think that's the way that patterns work. If it was not, it would end up binding it to a list. All a bit fuzzy. Let's get a fail. How many failed? I thought you said 4 failed. No, one failed because we don't support parsing those forms yet. So what we want to do here is we'll do a list.fold. We're gonna say what are we gonna, so the folder takes the thing we want to fold with, the state, and then the list. So we'll have some state and some node. Let's call them state and node. What are we gonna do? I think we'll say is the, do you want to, we could, what do we want our states to be here? We could build up the list of let's build up the list like this. Let's have none or something, and then we'll set this to sum if we've seen something. This will be a list of errors, and this will be a list of results, and then from the inner parsers. This will be an optional result. So we'll say match node. Well, we kind of need to know if we've seen we need to know if we've seen a dot. State dot 1. Can I do that? No, not what we want. What are you complaining about? Let's go have a look at how we did it in the when we're parsing, well, binding the formals, which aren't quite the same structure, but bind formals. So this is bind formals list. We say list.fold again. Well, yeah, empty list, false, and none. And then we say if we've seen a dot and there's already something in there, we make a diagnostic. And then if it's an ident, we don't need to worry about the what's after the dot. We can just find that. We can just do the macro parsing the same way we normally do and push it onto the end of our and set it as our sum value. Then if it isn't and it is a dot, we set dot to true. Okay. And then we'll have a case where we handle ellipses in there. So if, well, the first thing it did was unpack the state. So let's do let. So these are going to be patterns, pats. It's shorter. Scene dot and dot pattern dot pat for consistency, and we'll say if we've seen the dot, so if we've seen the dot, we would expect to see one thing. So we'd say if dot pat is sum, we will return an error. So we'll say results dot error. We need to make a diagnostic. The diagnostic is going to be at the node location and the value is going to be unexpected. What we say here? Only expected a single. We'll say only expected a single pattern after dot. Okay, and then if there isn't something in there, then we just say return the existing patterns scene dot and some we're going to have to recurse here, so pass pattern node, so that will produce some parse pattern. Dot pat is used, it's used there. So if we haven't seen a dot yet, we will match the node if sorry, if the node kind is dot, do pat, that's true, non, or dot pat, I guess. And for anything else, we will do pass pattern on the node, paste it onto the front of the list, return and dot pat. What are you upset about? It's upset because we don't do anything with the value yet, so that needs to be let patterns scene dot pat. Now this is unhappy because that needs to be doesn't know what dot pattern is. So non option result macro pattern. Okay. Ah, that needs to be that. Type unit does not match the type. Maybe if I try building it, I'll get rid of those errors. Nope. Why does it think it's unit? We need so some dot pat So if there wasn't something, we'll pass it and we'll say if we, and we can't do that because it's inside. Or can we? I don't know. Let's see. Why does it still think it's indeterminate? When I hover over it, it seems to know that it's a macro pattern result. Why did the binder get away with it? It didn't. We explicitly stated. Let's do what the binder's done as well. Move this out into its own function. Let's bind form element. And bind form element is going to take a state, we can do them as a tuple, can't we? State node. No, it must be. It doesn't want to be a tuple. It must be state and a node, and can indent things a little bit now. So in this case, dot pattern. This dot fold. Bind form element. What? So we're now back to that one thing. We need dot pattern to have some kind of type annotation, I guess. Which is going to be awkward because it's going to be option result macro pattern diagnostic. And what's diagnostic upset about? I think that might be the error from the other place. Yep. No. Value diagnostic. Oh, it's just because I've spelled diagnostic wrong. Looking good. Well, we're still getting an error. Let's go. Macro pass tests. Could not pass macro pattern diagnostics. Unexpected dot. Is this because we don't actually do the it's because we don't actually use this thing that we've just done. So then we want to say let's well, I'm going to say if we've seen a dot and we don't have a dot pattern, and dot pattern is none, we want to return an error. Why are you indented like that? That's just ridiculous. Right. So if you've seen a dot and the dot pattern is none, then I want to say results dot error. Diagnostic is going to be, well, we can do it for the whole form, I guess. Nose. Is it nose? What are we matching over here? Syntax. Syntax, location. And so the error is saw dot but no expected pattern after dot. And let's do that the same way we do everything else by piping it. I have to put as many brackets around things. With that out of the way, we don't have to worry about, we can just concentrate on the dot pattern. So we can say match dot pattern. If we have a dot, then do some dot related stuff. If we don't, then we just return, well, we can do what we did before. We can do pats collect results and then results dot map macro pattern form. So take all the results, collect them into a single list, and make a form. If we have a dot pattern, we want to take the patterns and collect the results, just as we do in the other case. And then we want to, what's going on there? There's a lot of extra space. We want to result.map or do we want result.bind? Result.bind, I think, takes something that could produce a result. Could produce an error. And we do have something that could be an error. Which is our dot pattern. So if we've got our list, so that's going to be pats and the list of macro patterns. We will say match the dot if the dot is okay, we'll make a macro pattern form. A dotted form, with our pattern and the dot. If it's an error, we'll just return it. And what have we got there? Hopefully a result that's a macro pattern. What are you upset about? And yeah, okay, so do we just want to do that? No. So it takes 2 balls and returns a ball. Use expression 1 and expression 2 instead of, okay. Type unit does not, well, value is not a function and cannot be applied. Yep, because we need to do that. What are you upset about? You're still D. Type unit, not match the type. We need to do an if else, because if you've got a 1 arm, if both have to return unit, which makes sense because it's the only logical value that that expression could have. What have I got selected? Just seeing lots of weird orange bits on the right hand side where it highlighted every result. Okay, so what have we got now? Why can't we? So it says fail because assert.true failure. Why has that failed? That should be. Looks like a dotted one now matches. Yeah, the dotted one passes. The plain form doesn't. Interesting. There's something in here. And it was just saying that it didn't match, not that we failed to pass anything. Let's go debug that test. Macro tests. One. It's going to be awkward because it's got all these different variants, but we can just comment them all out for the time being. And then debug that one, macro pass tests. I think it doesn't actually matter which one of these I choose. It just ends up trying all of them. Yeah, it is. I mean, this Test Explorer thing isn't the greatest, but it is the best that there is available in VS Code. So that's what we have to live with. Are you going to attach anytime soon? Yep. Are you going to hit the breakpoint? Please hit the breakpoint. Nice. Right. So we have A1 and test. So why is this not why is this not working. So step in. So we can probably ignore read single node. So pattern kind, it is a form. So we're going to say find form element. Form has A and 1. That looks correct. That's... So we haven't seen a dot. So that's good. So we go collect results. So that's going to be, I don't know. Let's step in and find out. Results may be error, match may be error with none, so there are no errors. So it returns the results. Result.map is going to turn that list into hopefully a pattern. So we've got a pattern. Syntax tree. The syntax tree is test, and then that looks acceptable. The pattern is a form with a constant number. Ooh. See what's happened. It's the wrong way around. That's awkward. But it is fixable. So in our macro parsing, we are pasting all these together when we do the list.fold, and we're reversing the list as we go. So this is a bit awkward, but I think the easiest way out of this right now is to just reverse the, rather than reversing us pasting this on the front of the list here, which is what's doing the reverse. One option is to rewrite or try and rewrite this method into a recursive one that uses an accumulator or something. We start off with that, and then we can recurse into the inner one and then paste R1 on the front. Or we just reverse the patterns that we get out. I'm tempted to try the first way because this isn't the most elegant using this fold, so it might be better to try we've got the patterns. Where would we want to? We could just reverse them here, couldn't we? In this bit, let pats equals list dot rev pats. Then hopefully that test should now pass, and we shouldn't have broken the other ones. Actually, that's a good point. Let's go and uncomment all of these. I think I got there in time for it to run those tests. Yeah, it was 203. That's good. So that works. We can commit this as is and then try and have a go at fixing it. So this is add pass support for macro patterns. Try and pass pattern from syntax tree. Support. Yeah, we'll leave it as it is for the. Well, doesn't support literal identifiers or ellipses. Is that correct? Who knows? So let's try and rewrite that so we don't have to do the list reverse. So I think what we want is something like let bind, not bind, we're not pass form is going to take what? Well, it's going to return the same kind of thing. It's going to return a list of patterns and the dot. But we can pass the scene dot down. So it's going to take a pass form is going to take a nodes, which is going to be the list, scene dot and nodes, and it's going to say if we've seen dot we can say match nodes. If we get a single element list, then we return OK with, well, actually we return pass we return nothing in the prefix, and we return some of pass pattern. Wow. Pass pattern the node. So we try and pass the node if there was one. If there was any anything else, we can say and we can actually have this as the dot location, can't we? So if we say like match dot location, and then if we get some location, we know that we've seen a dot. we pass, we can make a diagnostic that points at the dot that you made the error with. So we can say only expected a single pattern, sounds like an acceptable error. Just copy that, but that can be dot location. And this will be an empty list followed by this diagnostic, which is starting to look like it's the same. So can we do this type to sum? Result error. Make that into something. That wants indenting, I think. No. Like that. Wonderful. So I think that's going to be the case. That's going to handle all of our dot stuff, and we don't need to pass this whole like dot thing, scene dot, back into the result. So now the result is just going to be this pair of the patterns we've passed and the dot pattern if there was one, or an error about the dot if there was an error. So then if we don't have a dot location yet, we will match the nodes, I guess. So we can match the head, I guess. Or should we just match? Yeah, match nodes. And if it's empty, we will return that. So this is the case we've bottomed out the list of nodes. In the other case is something, we've got something where the kind was a dot. Is that right? No. How do you do the catch-all bit? I must do this in the binder somewhere. Oh, you just say kind equals blah and then that's it. You don't actually need to say anything else. Fair enough. So if you got something that was a dot, we will do pass form on the rest with the dot's location. We will say pass form. No, pass form. This needs to be recursive. Pass form with the location and the rest. And what are you upset about? Expected to have text location. Okay, so that just needs to be some So we pass it down, and there was nothing, we've bottomed out. If there is something in the list, node and nodes, rest, we will say, and then this is the bit where we're just gonna match the tail. So we'll say let pats and dot pat is pass form on the rest, and then we will return pass form on the node pasted on the front of the patterns with the dot pattern on the end. That might work. That wants to be dot block. What are you upset about? Arguments involving function applications should be parenthesized, which that technically is. Okay. And this one is saying the types A and list A result. Expected A, but given that wants to be pass node. Pass pattern. It's only passing a single pattern. Right, so with that, instead of doing all of this, we should be able to say patterns and dot patterns equals pass form non f. Get rid of all that. Then we can say don't reverse the patterns. That I think is simpler. Let's see if it still passes the tests. Tea is cold. It still works. What's the change? Yeah, I think that makes it simpler. Simplify parsing of forms, macro form patterns. Rather than reversing the list, use recursion to build up the list. Correct. Boom. Yes, commit it. So we've got parsing for forms which don't have ellipses in them. let's add support for the literals. So literals is going to be literals is going to be a list of the identifiers. Test is going to be upset because we've just got rid of that. Try match. We're going to do parse pattern with an empty list because we don't want any literal identifiers for the time being. Then in here, we will say, actually, go on, we'll put literals. So we say try match literals pattern. And then down here, we will have try match, and we will say, what do we want our literals to be? Foo. Good. I could make them another argument to the inline data, but and then in this case we'll say if I do foo, I would expect this to match foo. In fact, let's simplify that right down to just the identifier foo. So this should be a literal. And let don't want to do assert.true. Let's do assert.equal should match. Oh. I think VS Code is giving up. Hey Spellbook, what is going on? Come on, code. I don't want language components. Mono framework assemblies. That's all great. Boom. Right. What are you upset about? Still not working. No, I had a problem last week with it not being a great fan of the backtick identifiers and stuff. I don't really know what's gone wrong this time. Oh, all of my commands are buffered up. Reload the window. Right. So we've got should match. Damn. Get your act together. No, when it's loaded where everything goes green. Well, by everything I mean the identifiers. There we go. So, literals. Here it has the type string list. Well, what do you know? Literals, parse pattern, literals, AST node. Why do you think that literals should be an AST node? It's because we recurse in a few different ways, and we should make a recurse. So recurse wants to be pass pattern with the literals, and then we can add all the other things on there. And then instead of calling pass pattern, we call recurse. Whoop. And that's it. Looks like it might be it. Still saying it should be. I think that might be an out of date warning, but we'll never know. Test. Yep, it's running the tests, so it must have compiled. Turned false but did not log an error. Nice. Hopefully code can get its act together, and then I can actually try and write that test. I saw the error there. Are you gonna right? Unknown test case. Report results reported for unknown test case. Sounds mysterious and is almost certainly something to do with that test plugin. So let's go macro tests. Inline data. So we just want to say true for all these. So we should multi-cursor because we're too lazy. And then we can say that one's failed miserably. That has failed miserably as well. What is going on? Right, I'm going to kill all .NET. Yeah, well, the October version has been super flaky so far. I'd rather you didn't try and install it. Sometimes you have to restart VS Code a few times when it's trying to install an update for it to actually get around to or stabilize on the state it's expecting, because sometimes the plugins are loaded from the wrong version. I think that's what we're in. I think someone's shipped some code and it's ruined my day. What a surprise. Right. Should have turned do not disturb on. Set equal. Should match. Now let's try building. There's a lot of red, which is interesting. I don't know if that's coming from the ionide or whatever. I don't know if these are coming from the compiler on the command line stuff when it's actually doing the compiler, or if these are coming from the language server. There's so many of them, and it all compiled a minute ago, that I'm super suspicious. 99 warnings. And it's only in the file that we have open. Try reopening it. Macro tests. Yeah, still there. Building. Tell me about it. Yeah, it builds. Tests. Oh dear, it's boating. Oh well, I think we'll restart OmniShop. Oh, it's still loading. Key is, if we do the run test tasks, what we want to do is say, like, foo should not be able to match anything else, because it should be a literal. There we go. So do we get that one correctly not matching? Ah, well, we actually haven't done the work for it yet. We want to say run test task. What do we want to do? We've got an ID. To do support ellipses, and we'll do when L when L dot or list dot contains, and the L literal. So if we have, if the literal list contains that value, we'll do a macro pattern literal for that. What are you up to? A function when list contains, okay. That should work. One failure. Hopefully zero failure. Zero failure. Good. So that's another thing to check off the list, which is add support for literal parsing. And that's an uppercase I. Literal patterns only match their respective ident. there's a little bit more to that, which is when we actually no, I think that's it. I don't think, I didn't know whether or not you can match something that is a literal with a variable pattern, but I don't see why you wouldn't be able to. So the last one is, well, yeah, we could support ellipses in the form. But really what we want to do for ellipses is, well, for a start we need to add support for them in here. So repeat of what? Macro pattern. So this will match any number of that pattern. So how do we parse that? Well, how do we match it? Right now we'll just say repeat pattern. We will just do fail for the time being, I guess. Not implemented. We're going to need some kind of recursive pattern matching strategy there. But parsing it, we can parse it in the form. So if we get what do we want here? Can I do, if we get the ellipses, now it needs to be like kind equals dot. No, sorry, kind equals st node kind ident. How do we want to pass this up? Do we want to have this, like, do we want to, because we're kind of building the list of patterns up, what we'd have is like, we'd see, we could see on the way down or on the way up, we could see that we are at a dot. But what we really want to know is if the next node is a dot. So it could actually be that we do that in here. So we're saying we're going to, we've got our node here. So we make a pattern out of the current node. And then we say match rest with, and then we say if we've seen something that is a if we've seen something which is a pattern is an ellipses, ident. If we see the dot dot dot, rest, otherwise then we will let's do again, let's do pat equals, we'll recurse into the thing. No. We want to create the pattern, and then if we've got an ellipses, we want to wrap it effectively. So we'll say pat result dot map macro pattern dot repeat, and then anything else is the pattern. Then yeah, we need to tell it what the rest is as well. And then we can do this is that rest. And then we get the inner patterns and then paste our pattern on the front. That kind of looks like it might work. Let's add a test. So we'd expect one dot 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 to match one dot 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 to match 1 1 1 1. But we wouldn't expect it to match 1 2 3. What is going on? Why is this keep on crashing? So we'd expect at least one of those to fail. Yep, 2 fail. Oh, because we are going to get an exception when we try and match it. Yeah. So let's try and implement matching support for repeats. Really, I think that a repeat at the top level here should actually be an error. So let's actually say repeat at top level. And I think we should just never ever produce a pattern that contains that and consider it a compiler error if we've passed something that does contain a repeat like that at the top level. because we should have omitted a diagnostic sometime earlier and not actually tried to match that pattern. Then we want to say if we're matching a form or a dotted form, I think this wants to become match form rather than match dotted form. Which takes a pattern, some tail, and G. And then this would be match form patterns none and G. And then you can see that forms and dotted forms are the same, really. Patterns, and then we rename this to match form. That's going to be a tail pattern, is going to be an option. Match form. So then we can handle the repeat case in here. We can say if we've got a macro pattern repeat, repeat to do I'll just fail repeat support. So yeah, we'll handle the repeat case here. So we're walking through the list of patterns. If we see a repeat, I think what we want to do is try and match the tail against the remaining patterns against the rest. And if that works, we can just return that. And then if it doesn't, we try and match it once, and then try and match the tail, and then so on and so forth, just building up a list of pattern matches. Until if our repeat fails to match, we return that error, or we've run out of things in the patterns list. Yep. Then in here, macro match tail pattern. So this is the case where we've got to the end of the list of head patterns, and we want to say match syntax. I think we want to say match. So if we have, I'm going to call this maybe tail. Oh yeah, that's the pattern. I want to do that up here. Maybe tail. We get some. we've got a tail pattern. Then we do what we were doing before, which was to try and match the tail pattern correctly. If we got none, we return if the list is empty, syntax. So we've run out of patterns and syntax at the same time. Then we do OK with nothing. Otherwise, we return an error. Because we've still got stuff to match against, and we're supposed to match the whole pattern. Right. Fix me, need a way to bind this. Interesting. That's for the case where we have the tail is a variable and it's supposed to match one thing. We need another way of representing that in the bindings, but that's another job unrelated to what we're doing right now. Does need fixing though. So if we've got a repeat, let's say if we have a repeat, we're going to do some kind of loop. So let match repeat tail. Match repeat. Let's do match repeat. Against a tail. Let's just make this. What do we want to say? Yeah, let's just call it right now. Let's call match repeat. So we want to say patterns is going to be rest. And tail let's get rid of that. So let's say what we will try and do is match the form against the rest of the pattern against the whole syntax. If that was okay and we got some variables, we'll return those variables. If it was an error, then I want to say match pattern macro match repeat syntax if the syntax has got something. And we do macro match the repeat against the head. If that worked, if this fails, so we've got to a point where if we get to a point where the repeat fails to match, then we say we return an error. If we get to a point where we run out of syntax to match against, if we run out of syntax to match against, is it an error or is it all good? I think, because is this the case where where an ellipsis is got to the end of the list and everything's good, or is it the case where we've got to the end of the list and the tail pattern bit that's after the repeat has always failed to match? I think it's the latter. So anything else, and we'll return an error. And we'll put a little bit of a comment there to say ran out of repeats and tail never matched. Macro pattern option, that needs to be maybe tail. And macro match. That's gonna say files, I think. Then we need to recurse in some way as well. There. You can. That needs to be okay. Files okay. That wants to be okay files as well. And the error ran out of tails. Okay, so this whole thing here really wants to be its own method that we call, which is going to take a repeat, a set of patterns, maybe tail and syntax. So let's try. And match repeat. So if we got a match, we'll try and do a match repeated on the inner one as well. So we'll say I think this is going to be a result.bind we can do here. We'll just say match the inner one, and then result.bind match repeated, repeat patterns, maybe tail, syntax. So basically you try and match the head and then try and match the tail with the match repeated again. What are you upset about? At or before this point? Yeah, it's up here. Match repeated. It's going to take repeat. Patterns is rest, which we can just call patterns or pats because we seem to have been doing. Maybe tail and syntax. Good. Now what's happening down here? Maybe tail. Match needs to be patterns. So basically we try and do a standard form match. If that works, we return it. And so this is going to be, this is the way that we succeed, is if we try and match the tail patterns and they do exactly match the rest of the form, which would even include the patterns being empty. So if the patterns were empty, we'd come through here, we'd try and do the tail match. If the tail matched cleanly, we'd end up with some result. If we didn't have any tail, that would also be, so this is the case where we've just got one ... we'd come here, list none, and we'd come, as long as there's no syntax left, we'd get okay. So that's how we successfully exit out of this recursion. And if we don't manage to successfully match the tail, then we check to see if we've got any more syntax to match. And if that works, what are we doing here? Got match repeated. Is going to return a list of macro bindings. So we want to paste these two things together. So if we got some, we'll do match repeated type to results dot map list. Basically we just paste the two lists together. That needs to be maybe tail with the right casing. I think that's working. Let's try running the tests. If they compile, that's a bonus. Well, there was some failure up there. What happened? Expected, true, actual, false. Expected, true, actual, false. Well, the second one shouldn't match, so that's a broken test. This one should be false. But why is this one not matched? Let's... Oh, no, that. That, yeah. We comment all this stuff out. We can debug the test again and see what happens. Something's not quite right. So did that just fail? Did we fail to pass it or something? Debug console, why have you failed? It says it worked. We just want to refresh that so we've got the right list of tests. Macro tests, macro pass, debug. So, stepping in, hopefully it passes. It does. We get some syntax. So macro match, what's it going to do? It's got a form which has match the kind, so it's going to try and match the form, match the patterns. The patterns, what are the patterns? Oh, variable dot dot. I just messed it up. Oh. This is going to be great when you see the fix. That was being passed as 1.0, followed by the identifier that. And now should be able to run the whole lot, and they should all pass. What's gone wrong here? Is this a test that I can't? What's this one? Yeah, that's because that's not there anymore. Refresh. It still thinks the macro test have failed, but it hasn't got a failed test example in there. So I think that is... I think that's the way that these kind of patterns are supposed to work, and so it's a case of so something like any number of ones followed by a 2 followed by anything, I guess. Let's say any number of ones followed by a 2 followed by anything. So we just match match that, then we can say that should match that, and it should also match when we've got other things here. 1 1 2 3 4. Because we should not be able to match the 2, so we match the 1 pattern once, then we still can't match the 2, so we match the 1 pattern again, and then we can match the 2, and then we've run out of patterns, but we've got a tail which matches that because it's just a variable and everything's good. Right, I've just run the tests. So that is repeated elements and parse macro patterns. Add support for repeated elements. Repeats match correctly. Still needs unparsing. So the one problem that I think we still have here is we haven't done anything in the parser to deal with what happens if I put more than one repeat in there. That should be an error because you're only allowed to have one repeat in each form. Our code would be able to match them, so I'm wondering if this starts getting into the territory of maybe we start emitting warnings as well as errors or something like that. But strictly according to the scheme specification, you're only allowed one. And it's because if you were to have more than one repeat, so like it becomes really odd how they work if they were repeated variables. So like if this was A and then this was B, but B was also repeated, what would happen is it would try and match the tail, which is B repeated. So B is just going to go and try and match blah. Well, actually, if we didn't have the C, for example, B would just match all of the rest of this because we'd be recursing in and doing the match for this part of the patterns against this whole list, and it would just keep on going until it matched, succeeded, and then A would match nothing. So anyway, that's a job for another day. So that's it, and I think we've completed what we set out to do in this stream. Macro patterns now are able to match repeated elements, and we've added parsing support so that we can take a piece of syntax and convert it into a macro pattern. So in the next stream, hopefully I will be able to start looking at trying to recognize syntax definitions in the source code and actually expanding these macros, or maybe we'll have a look at producing built-in macros so that we can expand out things like ands and ors, which is really where I want to start using macros, because writing and an or as special forms, really it's better if we write them as macros. Yeah, means less specific code in the compiler. So ideally you'd only really have function application, macro application, and ifs as your special forms, but we'll have a few extra, but we'll have some compiler built-in macros as well. So anyway, thanks for watching, and I will see you next time.